Hello again and welcome. Over the past year, several of you have asked that I have a look at the UNI-T UT61E Plus. This meter's on the right. For those of you who are superstitious, this is going to be the 13th UNI-T product that I've looked at. There's been 8 unique ones that I've transient tested. Those include the UT90A, the 139C, the 15C, the 10A, the 20B, the UT61D, the 61E, and of course my favorite, the UNI-T UT181A. Although I've never ran those across this transient generator, I've also purchased a couple of UT210 clamp meters. I found this one for just under $90 on Amazon. That included shipping. So it's roughly double the price of my original UT61E. A few people, including Dave at the EEV blog, have reviewed this meter. I thought his presentation was pretty good. There was a couple of things I noticed that I didn't necessarily agree with, and I'll go over those during this video. So of the 8 meters that I transient tested, several of those were taken out either by the full wave rectified AC line test, or they've been taken out by this small grill starter. Now again, this meter is brand new. I haven't even opened the box yet, but I'm going to go out on a limb and say that this meter would not survive the transients coming off of this grill starter. And for those of you who've watched the videos where I've modified this particular UT61E, let me show you why I believe that this meter is going to fail. If we have a look at the back, so right here, I believe that this is the frequency counter. You can see both the 61B plus as well as the D plus can read up to 10 megahertz. Notice the 61E plus, this shows it can read up to 220 megahertz. So that's crazy fast, and if you recall with this particular meter, the problem was because this could read those same very high frequencies, what ends up happening is that transient basically gets coupled directly into the control IC. So if you're interested in the details of that testing or how I modified this meter to survive that transient, I'd highly recommend that you have a look at that video. So let's just go ahead and open this thing up and have a look. Looks like this particular meter was manufactured in June of 21, so it's a fairly recent version of the meter. It comes with the USB communications adapter, a decent set of leads. Let's go ahead, we'll pop the back cover. Again, if you watch Dave's review, nothing you haven't seen before. So we'll just use the batteries that were supplied with the meter. Let's go ahead and power it up. Looks like it powers up just fine. I think what I'd like to do first is we'll just run this thing through a basic functional test and make sure that the meter checks out. So let's just start out. This will be 2.5 volts AC. Looks about right. Let's try it in frequency. Yep, it should be 60 hertz. Let's try it with a DC coupled, and that is 60 hertz as well. So again, we don't have the zero crossing in this mode. This will be 30 hertz, 15 hertz, 120 hertz. That all looks fine. This should be a little over 3 kilohertz. Looks about right, 3.19 kilohertz. Let's go back to AC volts. This should be roughly 70 volts. Looks fine. And let's go ahead and try it with the DC volt mode. This should be roughly 60 volts. That looks fine. So it has this AC plus DC mode. Let's try to turn that on. Oh. Really? So it doesn't actually have an AC plus DC mode. Normally this mode is going to provide you with the square root of the sum of the squares. Unfortunately, all this thing is doing is flashing between the two modes. So let's just see. Yeah. For this mode to be useful, the meter really should perform that calculation for you. Anyway, so let's just try it with our 5 volt. You can see it's off maybe 1 or 2 counts. Let's go to the millivolts section. This should be roughly 115 millivolts. 118, that's pretty typical. Let's go to DC millivolts. This should be roughly 20 millivolts. Looks good. Another thing I noticed during Dave's review, this meter lacks a temperature input. Instead, they've opted to add this HFE mode, which isn't something I'd ever have a use for. Let's just try looking at the frequency in AC millivolts. Again, this should be 60 Hertz. Looks like it's spot on. Let's go ahead and we'll look at resistance. So with the leads open, we can see it's not having a problem with that. Let's just try it with our 100 mega ohm. Takes a while to settle. Of course, as you move your hand near this, it's gonna upset that reading. Let's just try it with our 10 mega ohm. Again, this is a 0.1% part. Looks really good. This is a 1 mega ohm, 1% part. Really good, and you can see the meter is settling out much faster. This is going to be a 100K 0.1%. Really good. This is a 10K 1%. Again, really good. Say 1K 0.1%. Really good. This is a 100 ohm 0.01%. Let's go ahead and zero the meter out. Let's try it with a 50 ohm. This is a 0.01% part. And this is a 1 ohm 1% part. Looks good. Let's just go to the next mode. So this is continuity. Let's go to Diode Check. And again, this is with a short. Here's a standard silicon diode. You can see 0.635. Here's two in series. Let's just try our white LED. Can't read the open circuit voltage on this, which would be roughly 2.5 volts. But it is able to light the LED. For some reason that's important to people. I don't know why. Let's try it in capacitance mode. So let's just start with our 150 picofarads. Wow. This is extremely fast. Let's try it again. Jeez. I've seen meters that'll take 15-20 seconds for them to settle out. That's really impressive. So this is a 1 nanofarad capacitor. Jeez, again, very fast, spot on. This is a 0.1 microfarad. Really good. Let's try some higher values. This will be a 1 microfarad. Really good. Here's a 10 microfarad. Looks good. And this is our 100 microfarad. Yep, again, really good. I think when I was looking at the Bryman meter, we were reading 104 with the flukes in that latest Bryman. Let's just go to current. It does not have a lead check. I wasn't really expecting it would. So this will be 100 microamps, 10 microamps, 1 microamp, and 0.1 microamps. Looks fine. So off to my left I have the BM869S, to the center the UT61E Plus, and to the right the BM789. All these meters are currently in series and they're connected up to my bench power supply. You can see we're putting out roughly a 0.5 amp. This is about the limit of our power supply. You can see we're putting out roughly 6 amps right now. Let's have a look at our burden voltage. So about 340 millivolts or so. Looks like our UT61E is about 141. So they've definitely changed the shunt. Let's have a look at our 789. Well, very similar, about 140 millivolts. So the burden voltage for the BM869S is about 2 times of that of the newer Bryman as well as the 61E. Again, all 3 meters are in series, but you can see I've changed over to our milliamp ranges. We're currently putting out roughly 40 milliamps. So now let's have a look at our burden voltage. So for the BM869S, looks like about 69 millivolts. For the UT61E Plus, looks like about 210 millivolts. And let's have a look at the new BM789, about 95 millivolts. Of course, that's one of the shortcomings of this UT61E. The burden voltage for this meter was very high, and you may remember I made a video where I'd modified this meter and I've added a chopper amplifier. Let's go ahead and turn the current up a little bit. See how they track. Looks like all the meters are fairly close. Maybe the 61E is running a little on the hot side, but probably well within tolerance. We've now changed over to the microamp ranges, and let's have a look at the burden voltage here. So roughly 36 millivolts for the BM869S, about 176 for the UT61E, really poor again, and about 36 for the BM789. Of course, if you're curious how that compares against our modified UT61, let's just have a look. So again, you can see the current's reading roughly the same value. Again, this meter has our adaptive backlight. Anyway, so let's have a look at our burden voltage for our highly modified UT61. There you go. 3.74 millivolts. Compare that again with our 869 at 35 millivolts, so about 10 times less. And again, here's the 61E Plus at 174 millivolts. So again, that was a pretty good improvement for the 61E, but it really only improved the one range of the meter. Unfortunately, to modify the other ranges, there was no way easily to do that with the function switch the way it's laid out. You can see I currently have the 61E Plus set to its frequency input. You can see I just have a banana to BNC adapter. This is going off to our RF generator. And you can see I'm outputting roughly 1 megahertz. So let's go ahead and turn this up a little bit. We'll see how it handles higher frequencies. This will be 2 megahertz. This will be 4 megahertz. This will be 8 megahertz. 16 megahertz. 32 megahertz. 64 megahertz. 128 meg, and you can see the signal's dropped off. We probably have to increase the amplitude a little bit. So currently that was with a 0 dB or 0.3 volt signal. Of course, we're unterminated on the meter end. Let's go ahead and turn this up just a little bit. I'm currently at 20 dB drive, and the meter is still unable to pick this up. Let's adjust the frequency down a little bit. Looks like it rolls over right at 100 megahertz. Yeah, I don't know if that's a limitation of the meter. They claim 200 megahertz. Might be interesting to increase the signal a little bit further and see if this thing can actually read above 100. So off to my left, you can see I have a little power amplifier. This is connected directly into the meter. Again, it's unterminated. For this test, we're not really going to worry about that. You can see we're outputting roughly 92 megahertz or so. Let's go ahead and increase the frequency now. Ooh, that's interesting. You can see how it's dimmed out the display. This is 117 megahertz. Of course, I've increased the power quite a bit. Let me just turn it down a little bit. And you can see the meter's having a lot of issues with this. Yeah, it's pretty funny. So that's where the contrast gets the worst. As we start to move beyond that, you can see the contrast comes back. So there's 125 megahertz, and that's about the limit, even with this large power amplifier. Let's turn up the gain a little higher. Yeah, right there, about 126. We can go up a little higher. 127. Oh, and again, rolling over at about 127. Let's grab a different amplifier. Alright, so I've brought out another amplifier to drive this one. Let's just see how it does now. I'll go ahead and bring the power up a little bit. Again, I'm set at about 130 megahertz right now. You can see we're putting out enough power to wash this thing right out. It's still not picking it up. Ooh, doesn't like that. You hear it beeping? Well, I can really feel the heat in this meter. We might have just cooked it. Ooh, look at this. 0 ohms. Yep, unfortunately, looks like we've damaged our meter already. You can see that, it's reading a dead short. Let's go to Diode Check. Yep, you can see dead short. Well, I would say as far as the frequency counter is concerned, it probably cannot read 200 megahertz. Let's go ahead and we'll take this thing apart. Unfortunately, you can't smell this, but yeah, we've definitely smoked something in this meter. In fact, we can even feel the case heating up. It is not a good sign. Looks like it's just the 4 screws. Oh, look at this. You can see the damage here. We've actually melted the case. There's one of the PTCs. It unsoldered that right off of the circuit board. Have a look. There it goes. You can see where that PTC used to sit. Right there is where it became unsoldered. Jeez. Well, that's not very impressive, is it? Let's have a look underneath the circuit board. Okay, do we have any other ones? I would think that these 4 are just for the display. Hopefully that all comes out together. So no real damage to the board on the bottom. Boy, you can just see the damage to it though. Well, there you have it, the UT61E Plus. Now the original UT61E could actually read these very high frequencies. I'm kind of surprised that this one couldn't. The fact that they've detuned this slightly, it may actually survive the ESD testing. It's hard to say. Well, I'll tell you what, I'm going to leave this meter sitting the way it is. For those of you who wanted to see this meter ran, I'm going to let you decide what to do with this meter. Well, I don't know if anything else was damaged or not. It's possible that we could repair the meter, but now that we've damaged some of this, I'm not really sure what we're going to learn from it. One of the things I'd like to do is maybe life cycle the switch, but as far as transient testing it, I'm not sure that we're going to be able to use any of the data that we've collected. You can see down here, you can see this is all the debris off of those PTCs. Boy, she got hot. I mean, I just glued that case right together. Well, let me know what you think. Again, I really don't care what we do with the meter at this point, so feel free to chime in, and we'll talk to you on the next video. Later.